Last time we discussed different types of functions such as constant function, linear functions, quadratic functions, functions involving absolute value, piecewise defined functions, cubic functions, polynomial functions, exponential functions, and logarithmic functions. But the discussion on functions does not end there. There are still many types of functions that are as important as the other functions previously discussed. Some of them are trigonometric functions. But before we proceed to discussing trigonometric functions, let's briefly take a look at first what trigonometry is. Trigonometry simply came from a Greek word trigonon, which means triangle, and metron, which means measure. So basically, trigonometry is just a mathematics that deals with the relation of sides and angles of triangles. But eventually, it emerged to the discussion on the concepts of trigonometric functions of real numbers. Now, trigonometry being triangle measurement is in fact the mathematics that deals with angles and their measure. Okay, since triangle is also about angles, so trigonometry is simply dealing with angles and their measures. But what is an angle? An angle is formed by rotating in a plane a ray M, called the initial side of the angle, around its endpoints until it coincides with a ray N, called the terminal side of the angle. So if this is, let's say, ray M, and this ray M is the initial side, and if this is another ray, let's say ray N, which is the terminal side, so an angle is a rotation formed by the terminal side to the initial side to the terminal side. Now, the point here, which is the intersection between, or the common point between the initial side and the terminal side, is called the vertex of the angle. Usually, it is denoted by V. Now, a counterclockwise rotation produces a positive angle. So if we have this initial side and this is the terminal side, the counterclockwise rotation produces a positive angle. Then the clockwise rotation produces a negative measure of an angle. Now, if we have two different angles with the same initial side and the same terminal side, those angles are called coterminal angles. So if we have this angle here, let's say this is theta, and suppose we have another angle. Say this one. It starts from the same initial side and ends with the same terminal side of theta. Let's say this is alpha. This theta here and alpha here are called coterminal angles. So again, coterminal angles are two different angles with the same initial sides and terminal sides. Now, if we have to create another angle here, but this time it's clockwise, say this one. Okay, and this angle here is, let's say, beta. So beta here has the same terminal side and the same initial side with the theta and the alpha. So therefore, these three angles here are also coterminal angles. An angle in a rectangular coordinate system is said to be in standard position if its vertex is at the origin and the initial side is along the positive x-axis. So if this is our rectangular coordinate system and our initial side is the positive x-axis and the vertex is the origin of the rectangular coordinate system, and if we, let's say, if this is our terminal side, this angle here, say this is our angle theta, is called an angle in standard position. So if we have another angle, if this is another terminal side, and if we have this angle here, okay, this angle, say this is alpha, alpha here is also in standard position. Now, if the terminal side of an angle in standard position lies along a coordinate axis, then the angle is said to be quadrantal angle. So if this is our rectangular coordinate system again, okay, and again the positive x-axis is our initial side, this is our initial side, and if this is our angle where the terminal side is on the axis of the standard position of the rectangular coordinate system, then this angle here is called quadrantal angle. Now if we have another angle, say this one, again the terminal side is along the axis of the rectangular coordinate system, then that angle, let's say alpha, is also a quadrantal angle. Same with this angle here, okay, then this angle here, let's say beta, is also a quadrantal angle. Now if the terminal side does not lie along a coordinate axis, then the angle is referred to in terms of the quadrant in which the terminal side lies. For example, here, this theta here, in this example, the theta here, this one, is an angle in the first quadrant, or the first quadrant angle, and then the alpha here is a second quadrant angle. An angle can be measured in terms of degree or radian. First, in terms of degree. An angle formed by one complete rotation is said to have a measure of 360 degrees, denoted by this symbol here. It's not an exponent 0, but it's a degree. An angle formed by 1 over 360 of a complete rotation is said to have a measure of 1 degree. Now, there are angles with special names because of their special characteristics. One is straight angle. Its measure is 180 degrees. We also have right angle that measures 90 degrees. Then an acute angle, an angle that measures between 0 degrees and 90 degrees. We also have obtuse angle, an angle that measures between 90 degrees and 180 degrees. Then we also have reflex angle, an angle that measures between 180 degrees and 360 degrees. Aside from these angles, there are also angles considered in terms of pairs. One is complementary angles. Complementary angles are two positive angles whose sum is 90 degrees. So if angle A measures 30 degrees and angle B measures 60 degrees, then angle A and angle B are complementary angles. Then we also have supplementary angles. Supplementary angles are two positive angles whose sum is 180 degrees. In this case, angle C measures 45 degrees and angle D measures 135 degrees. So therefore, angle C and angle D are supplementary angles. Degree can be divided further using decimal notation. So it is not always a whole number, because 40.75 degrees is also an angle measure, or 38.50 degrees is also an angle measure, which is in terms of degree. And also, a degree can be divided further using minutes and seconds, where 1 degree is equivalent to 60 minutes and 1 minute is equivalent to 60 seconds. So we can encounter that an angle measure which is 45 degrees, 25 minutes, and 36.5 seconds. This is also an angle measure, and that is a more specific measurement of angle in terms of degrees, minutes, and with this in mind, we can convert the measures of the degrees in terms of decimal to degree minute second form, or degree minute second form to decimal form. For example, convert 21 degrees, 47 minutes, and 12 seconds to decimal degrees. So we have 21 degrees, 47 minutes, and 12 seconds is equivalent to 21 plus 47 over 60. Why? Because 1 degree is equivalent to 60 minutes, plus 12 over 3,600. Why? 1 degree is equivalent to 3,600 seconds degree. So using your calculator, this is equivalent to 21.787 degrees. Now for number 2, 105.183 degrees is equivalent to 105 degrees, then 0.183 times 60 quantity degrees. Why? Again, 1 degree is equivalent to 60 minutes. So this is 105 degrees, 10.98 minutes. And then we can expand this further to seconds. So this is 105 degrees, 10 minutes, then 0.98 times 60 seconds, because 1 minute is equivalent to 60 seconds. So that is 105 degrees, 10 minutes, and 59 seconds. So we have this exercise set. For letter A, convert the decimal degrees form to degree minutes second form. And for letter B, we have convert the degree minutes second form to decimal degrees form. Aside from degree measure that we have mentioned a while ago, we also have radian measure. If the vertex of an angle is placed at the center of a circle with radius r, which is greater than 0, and the length of the arc opposite the angle on the circumference is s, then the radian measure of theta is given by theta equals s over r radians. Refer to the image. So we have a circle here with center at O and radius r. Then S is an arc. Actually, S is an arc length opposite our angle theta. And this theta is measured in terms of S over r. So therefore, from this equation, S can be computed by r times theta. Now, if S is equal to R, then what will happen to our angle? Our theta is simply R over R, which is 1 radian. So therefore, if this is again our circle, and this is our angle, if this is R, and this is our theta, and our S is equivalent to R, let's say S is equivalent to R, this measure here, this theta here is equivalent to 1 radian. With this in mind, we can now compute some measures of arc length with regards to theta in the central angle. For example, what is the radian measure of a central angle theta opposite an arc of 24 meters in a circle of radius 6 meters? So how do we solve this one? So note that our theta is S over R in a central angle, and our S, which is our arc length, measures 24 meters, and then our radius measures 6 meters. So that is simply 4 radians. Now the golden question is, what is the radian measure of 180 degrees? A central angle of 180 degrees is subtended by an arc 1/2 the circumference of a circle. So if this is our angle, okay, and this is 180 degrees, this is subtended to our S, which is half the circumference of the circle. Okay, this is our S. Now S is half the circumference of the circle, so this is S is equal to C over 2, where C is the circumference of the circle. And take note that the circumference of the circle is given by 2 pi r over 2, so that's pi r, that is our S. And take note that our theta is given by S over R, and our S is pi r over r, so you can cancel out r, so we have our theta is equal to pi radian. So therefore, the 180 degrees is equivalent to pi radian. Now if 180 degrees is equivalent to pi radian, or 180 degrees corresponds to pi radian, therefore 90 degrees is pi over 2, because 90 degrees is 180 over 2. Also, 45 degrees is pi over 4, and so on, with the other measures of degrees corresponding to measures of pi radian. In fact, okay, if we are going to complete the table with the idea that 180 degrees corresponds to pi, so this is 180 degrees, and pi over 2 is 90 degrees, and pi over 4 is 45 degrees, and therefore this 2 pi here is 360 degrees. So how do we solve for pi over 6, pi over 3, and 3 pi over 2? For pi over 6, this pi over 6 here is just equivalent to pi over 6 times 180 degrees over pi. Why? Because 180 degrees over pi is just equivalent to 1. So it doesn't violate a mathematical equation or a mathematical concept. So you can just cancel out pi here, so that's 180 degrees over 6, and that is 30 degrees. Okay? Again, note that 180 degrees over pi is just 1, or pi over 180 degrees is just 1, because again 180 degrees corresponds to pi rad. So let's have now exercise. For A, you have to convert degrees to pi radians. And then for B, you have to convert radian measures to degree measures.